Okay, after knowing about the indicators, now we are going to continue about titration. So titration basically is a method which is used to find out any concentration which is unknown for any solution. Okay, so to find out unknown concentration of any solution, we can use this method titration. Titration has many types. In your syllabus, you are going to talk about only one type of titration, which is known as acid-base titration, means mixing acid base together. Okay, for titration to perform, we are going to see first of all what apparatus we need, and then whatever thing we need for the titration. Whatever.
Miss,
Yes, Luna.
before you start, Miss, is this method can also be used depending on, Samarine's question? Like we can know the concentration of the acid, and then we could add
This
more
method is
alkaline. So
basically used to find out unknown concentration of anything for acid
yeah,
or
so this one can help.
yes, this one can come. So let's see the method, then it will give you all the answers for your question. So for titration, basically, we need two main things. Number one, we need a conical flask. Number two, we need a burette. Conical flask, you guys already know about this. Yes, Varif, your question.
Miss, I still didn't get it. What does titration mean? Like, why
Titration,
do it?
but let me explain. I'm going to explain the same thing, okay? Titration is an experiment or technique which is used to find unknown concentration. Got it? It's a technique used to find unknown concentration which we don't know. We want to find the concentration of some solution, so we can use this technique. So for this technique now, how we can do this? To do this technique, we need first of all some apparatus. We need number one, a conical flask. Number two, a burette. About the conical flask, it's a glass flask that you have seen already. In this flask, we will always take alkali or base, conical flask. Okay. The second thing is burette. Burette is basically a long glass tube. Most of the time, it can contain maximum of, starting from 0 over here, it can contain maximum of 50 centimeter cube or 50 ml of the solution. But some burettes are more bigger. They can take 100 centimeter cubes as well, maximum. The 100 or 50 will be at the top. Yes?
Miss, I have a question. Miss, in the conical flask, there will be either base or acid, or they can be mixed together.
Base. Base or alkali is going to be in conical flask. Acid is going to be in burette.
Oh,
Not mixed.
okay.
Separate. In conical flask, we take base, and in burette, we take acid. Okay. Now, the base that we are adding in the conical flask should have a known volume. Means whatever volume we are adding, we should know it as well. For example, I'm saying that let's add 25 centimeter cube of sodium hydroxide base in the conical flask. So 25 is known value over here. So known volume we are going to add in the conical flask, but concentration we don't know. Okay, unknown concentration. Concentration will be unknown for this base. Volume should be known for this base, and this base we are taking in the conical flask. Let's say I'm adding 25 centimeter cube of sodium hydroxide in the base, but I don't know concentration. Is it 1 mole per dm cube? Is it 2 mole per dm cube? Whatever concentration, I don't know. And I want to find this concentration at the end. That is basically the whole purpose of this titration method, to find the concentration of this base, which we don't know. We know the volume, but we don't know the concentration. Okay. So let me tell you how we can find. Later on, you will see as well. For the concentrations, basically, we can have concentration in the unit moles per dm cube. Okay. You're adding a known volume. It means the volume you know. It's 25 cm cube. You can change to dm cube as well. But you don't know the moles. So basically, your purpose is to find these moles, and from these moles, you can easily find the concentration. Getting the point? If you know these moles for this base, you can easily find its concentration because volume you are adding by your choice. How much? So volume you know. So these moles you can find by this whole method at the end. These moles you can find with the help of acid over here and with the help of a balanced chemical equation. Okay?
Oh, so Miss, we want to since it's an alkaline solution, so there's alkali or a base with water. We want to find the alkali, right? The number
Yes,
of moles for
concentration
the
means
alkali.
yes, concentration basically means how much base is there in how much amount of water. What is
Uh,
its concentration? Is it concentrated, diluted? So we are basically finding the amount of base in that water. That is known as concentration. Okay. So we are adding 25 cm cube of base over here. Let's say how we can add for this. We need a volumetric pipette. Volumetric pipette is just like a dropper, but it is more accurate. It can give you exact 100% accurate reading. So with the help of volumetric pipette, you are going to measure, first of all, let's say this solution is in excess in your lab. You need just 25. So this volumetric pipette you will use. It has a filler over here. You can press this filler and it will just fill the solution inside this dropper or pipette. You can take 25 reading will be somewhere over here. Okay, you can fill till 25 and then you can just drop it into this conical flask. Okay, yes, Samreen.
Miss, why does it say pipette safety filler?
Safety filler, because when you want to fill something in this one, just like you use the syringe has something at the back which can fill the solution inside, right? A
Yeah.
filler. Same way we have filler over here to fill it, plus it is closed, means it will be safe as well. No, the alkali will not come out from the top to make your
Oh,
hands damage or something like that.
oh,
Miss,
okay.
Yes.
there's a
Uh,
if you can see
hmm.
an opening next to the pipette, that
That
small hole.
small opening is for the air to go inside. Because if you want to fill something, we need air as well to remove from here and let the liquid fill inside.
Oh, okay, so it's for the air and for the liquid because
It's
we
for
can
the
fill
air
it in.
only, not for the liquid. Liquid will not come out
Oh,
over
okay.
us. We will not let the liquid to go inside. Till here, maximum we are filling the liquid, not inside the filler. Filler is just for the air to pass in and out, plus helping to suck liquid
Okay.
in the tube.
Oh, we remove the pipette and
We
we
will
fill it and then we put it back.
we will put it back, yes.
Yeah,
There,
okay.
there are three buttons basically. I will show you this in the school as well. It has one button to fill the liquid inside. Other button is to remove the air. Third button is to put the liquid back into the flask wherever we want. Okay, so this filler will help you and this pipette will help you to fill the solution, then put the solution into the conical flask 25 cm cube that we need. Now, the second thing is about burette. Burette is a long tube. It has a tab over here as well. This tab you can turn on and off just like the water tap. You can just open it, close it. If you close it, no solution will come out. If you open it, solution will come out. You can open less, more. If you want drop by drop, you can open less. If you want full liquid to come out, you can open it more as well. Right? Okay, so in this burette, you are taking the acid solution. You will fill it complete. If you want to fill it, you need a conical, you need a funnel at the top as well. Because if you're trying to fill in this small tube, let's say you're filling the solution, it will come out. Maybe it will be dangerous because it's acid. So you can put a funnel at the top, fill the acid, but be careful. Remove this funnel as well before you start the experiment because this funnel can disturb the experiment. Okay. After that, your next target is now base is ready, acid is ready, mix them together and see the end point or color change. Yes, Samri.
Miss, how can the funnel disturb the experiment?
How the funnel can, because some of the solution will remain with the funnel as well. And when we are filling this hole, putting the funnel inside, so acid will come out from the sides. Because funnel will take some space inside and it will make the acid come out and give a wrong reading. So we have to remove the funnel as soon as we fill the burette.
So, Miss, like the funnel, it is used to separate the solution, right?
Separate the solution? No, no, no. Funnel is used when we were doing the filtration. Funnel was used to
Filter
hold
paper.
the filter paper. Okay.
Like it is used to separate like a solid and like the liquid, right?
That was filtration method in which funnel was used to hold the filter paper to separate the solid from the liquid. Funnel basically has one side a big mouth. The other side is a small mouth, right? So we can also use them to fill something, fill the liquids where the opening is very less. For the burette, the opening is very small. If we try to fill, let's say I have this small opening and I'm trying to fill something with a glass of water, the water can just fall down from the sides because opening is very small for the tube. So in that case, I can use a funnel to make the opening bigger to fill the solution easily in the burette.
But Miss, I don't get how the funnel will disturb the experiment.
I will tell you. Just wait. I will tell you this again. So basically, you are filling this whole solution till the top. Okay. If you put the funnel, if the funnel will remain inside, funnel will take some space inside, right?
Yes.
When it will take some space, it means that amount of acid will fall out from the sides. So
Okay.
that will make the acid amount inside less, means the reading is wrong. So we have to remove this funnel to make the acid get all the space and do a perfect experiment.
Okay,
Okay.
Miss.
Okay. Now the next thing is to mix this acid and base together and get when they are going to change the color, and that is going to be the final endpoint. Now the problem is if this base is colorless, acid is colorless as well. If you mix them in any amount, they're not going to change the color. Both are colorless, both will remain colorless. How there will be any color change in that case?
Indicator.
So now, indicator. Now we can add an indicator which will help you to change the color over here because both are
And
color.
Miss, even we cannot use the litmus paper. We might use the universal
Yes.
indicator. Universal indicator can help with this one.
Yes,
Like it may give a
use
dark
indicator
green
paper.
color.
Yes, we cannot use here universal indicator as well. We just need one color. So we are using normal indicator here. How? So we are going to add 2-3 drops of indicator into this alkali. Indicator 2 to 3, 3 to 4, few drops only. You can write few drops. 2 to 3, 3 to 4, 4 to 5 drops only. Few drops of indicator we will add. As soon as you add the indicator, this base will not be colorless now. It will get some initial color, starting color. It can
So
be any
Miss,
color.
so Miss, the indicator is acting as 9-hydron when the chromatography.
In case of the chromatography, ninhydrin was basically an indicator, but it's
Yeah,
a
Miss, I
different.
was like,
But
yeah,
for
yeah,
the
Miss, I understand.
ninhydrin, that was not indicator basically. Why? Because ninhydrin was not giving you two different colors for acid alkali. It
Oh.
was just helping you to see the colorless points. But here the indicator means it is giving two colors for acid and base. Okay. So here we are adding an indicator. So this colorless solution will get some starting color. Now
Okay.
you are taking this solution over here, right?
A normal
Then you are going
indicator.
to turn on the tab for the acid. As soon acid will come to the base, what will happen? Neutralization reaction will happen. Acid base will mix and this starting color will change again over here. And as soon as the color will change, we will close the tab. Means the neutralization reaction is done.
Miss, when we will close the tab, when it becomes colorless again?
No, no, no. When it changed the color again. Maybe colorless, maybe any new color. As soon as it changed the starting color to any different color, that is the indication that stop the tab.
Okay.
Close the tab. It can go from pink to purple. It can go from red to blue. It can go from blue to colorless. Whatever color. Starting color will be something. Ending color will be little different from that. Maybe colorless. As soon as it changed the color, close the tab. Okay, so that will be indication that the neutralization reaction is done now. So it's changing the color completely. Okay, so over here, when you are, let's say you are starting from the 50 centimeter cube at the start, when you are going to turn on the tap, some of the solution will go down, right? You will see how much solution is going down. Let's say the starting was 50 centimeter cube. After the solution was changing the color, you are closing the tap. Now the remaining over here is 40 centimeter cube. So how much is used from 50 to 40?
10 centimeter cube.
10 centimeter cube is used. So means acid for 25 centimeter cube of the base, 10 centimeter cube of acid is used to make it neutral. Like this, we will see the value from the burette. Okay. So this was that was all about the neutralization reaction, acid-base reaction in the titration. If you have any question, you can ask. I will add few more information. Yes, Umama.
Miss, when we close the tab, right, there will be some drops left and they'll go.
No. Whatever drops are left inside, you are not going to do with anything with them. Whatever will fall easily, that's it. So you will
That's
just
why Umama, we don't have a 100% percentage yield.
yes,
Because
definitely. It will not be very 100% accurate experiment, but still, whatever 1-2 drops will remain over here, you will not shake it. Let it be. Whatever will fall down, that's fine.
Miss, I have a question. Okay, be
Yes,
fine,
any
and
other
we
question?
neutralized and we done everything. Now, Miss, where will we find the concentration in the mole and everything?
That's what we have to continue this further. Okay, so let me add few more informations over here. Basically, when we are going to put this burette and this conical flask under the burette, you have to remember few things. Number one, this conical flask, you have to put it at the top of a white tile. First of all, you're not going to put it on any black tile or a random shelf. You are going to put it on the white tile so that this color change is easy to check. Because if there will be black tile and glass conical flask is there, that will give some reflection and color already inside. So we use white tile to see a clear color. This is first thing that you will remember. And the second thing is that the burette that you're using, its mouth should be little inside the conical flask, not more down that it is dipped in the solution. No, it should be little inside. If it will be up like this, then the solution can fall out as well. So the mouth of this burette should be little inside the conical flask so that there is no splashes of the solutions. So I will show you it's written already in the text. I will just mark it with you that it will be easy to understand. Okay, now one more thing. When you are going to do this titration, you are mixing this acid with the base in the conical flask. You will turn on the tap a little. Why? Because you don't know that you need 5 centimeter cube of acid, 10, 20, 50. So you will open it a little, few drops will come out, and here you have to take this conical flask with your hand and shake it, so that when you are shaking it will keep mixing and proper mixing will happen and proper color change will happen as well. Okay, but there is a problem. Let's say acid you need to add over here, you need, let's say, 40 cm cube of acid, and if you are just putting 2 drops, shaking it, it will take more than 10 minutes, a lot of time to do this experiment one time, and that is a waste of time. So then there is a shortcut to do over here, and that is, understand this point very well. What is the shortcut? Basically, the shortcut is, let's say, do a rough titration. Rough means a rough reading. Perform a rough titration. What does mean by rough titration? It means open the tap fast, allow the acid to quickly come out. Quickly mix the conical flask. Acid is coming fast. As soon as the color is changing, close the tap. Let's say here it is 30 centimeter cube and color is changing. It means basically you got 20 centimeter cube of acid too, which is falling over here and giving you the reading. But maybe it was not 20, it was 19. Maybe because you are following the solution too fast, maybe extra solution is going out. That is the reason we say in it a rough titration. Rough titration will just give you an idea what is your range. That you are getting a range that right after 20 centimeter cube, near to 30 centimeter cube reading, the color will change. So you're getting a rough idea. So for rough titration, do the experiment quickly, get a rough reading. This rough reading is clear to everyone? What does mean by rough titration?
Open the tab quickly
Yes,
and yeah,
Do the
when it will
reaction
start
quickly
color changing.
and get a rough reading which is not accurate, which is maybe a little wrong reading, but that is giving you an idea at what reading the color is changing. Okay, now use that value and perform the actual reading. Now you will be having this thing in your mind. Okay, I'm starting the titration. I can start this titration quick. And when the reading will go near to 30, I will make the tab slow. Because now I know that near to 30, the color will change. Maybe you're just going till 28, make the tab slow, then one drop you will add, and you will get the accurate reading as well. So rough is
Oh,
telling
so
you the
so
range.
Miss,
That will save your time. And for the actual one, you can put the first few milliliters or centimeter cubes of the uh, acid over here quickly. And near to the rough reading, you can make the tab slow and add it slowly to get accurate reading. Yes, Varif, any
mm.
question?
So Miss, you're
No,
suggesting that at first when we what do you
Yes, Luna, 1 minute. Varif's turn, then I will take your question. Yes,
oh,
Varif.
Miss, I don't want, I didn't ask a question, but I just wanted to write what is the meaning of rough titration, so I can write it.
Wait. It's written already. You will just highlight the stuff. Just understand,
Okay.
then we'll highlight everything. Yes, any other question? Yes, Luna?
So Miss, so first you're suggesting that when we're doing titration, we do it roughly.
Hmm.
So it's like we're doing a mistake first, but then we learn from our mistake, so we get it accurate, and we get
Actual
a good
reading. So rough reading
actual
is giving
reading.
you some reading within seconds to save your time. And then you, after
Mm,
rough reading, you can do the accurate reading as well. Okay. Any other
okay.
question, Samri? And Umama raising hand. Yes.
Miss, basically the method of titration is first we have two conical flasks, one with acid and one with base, and we add the base to the burette.
Not two conical flasks. One conical flask, same we are taking here with the base. Burette is with the acid.
So Miss, the burette
Summary.
has the
Summary. We're using a pipette to know the exact volume of the base, and then
Hmm.
we're using the burette to know the exact volume of the acid. So basically,
Yes.
the conical flask at first was empty, and the pipette was full of base. So when
Hmm.
we drop the whole thing, so it's basically 25, and then we put it in front of a burette.
Yes.
Yes.
So conical flask is only one. Same we are taking over here with the base, and burette is with the acid. And then we are turning on the tap to mix the acid into the base in the conical flask.
so Miss like
And this mix,
the acid it will over time it will fall down to the flask, and
hmm,
then after some time we will close it.
yes, we
Like
will
when
close
we'll
it
close it.
and it will change the color here. Color change means the neutralization is done. The acid and base are mixed and they have produced something neutral, salt and water.
So Miss, that number will be 30 cm cube.
Let's say the starting number is 50, the ending number is 30, means 20 is used. The difference is telling you how much is used. 50 minus 30, 20 acid is used.
Okay, Miss.
Okay. Okay, so now let's highlight the stuff over here and then we will go to the concentration thing here, that how we got the concentration. So right now we got how much volume of acid is used, right? Let's move forward. So first of all, let's highlight the stuff over here that I already discussed with you. For the method, use the pipette and the pipette filler to exactly fill 25 centimeter cube of sodium hydroxide in the conical flask. Then the conical flask you will place on the white tile so that the color changes are very clear. tip of the burette should be inside the flask so that there is no splashes of the liquid outside. It will just go inside the flask, no splashes will happen. So it will be safe experiment. We are adding a few drops of the indicator, any suitable indicator in the conical flask as well to get a starting color because it is colorless solution. Now, this is very important experiment point. Perform a rough titration by taking the burette reading and running the solution 3 centimeter cube portions, like you are taking speedily 1 to 3 centimeter cube, mixing it, swirling the flask vigorously. Why? Acid base mix properly, give you some color. Then add 2 3 centimeter cube more from the burette, quickly just mix it, 2 3 centimeter more, quickly just mix it. You are not adding drops, you are adding more portions, big portions of the solution so that you can save your time. And that is basically rough titration. So rough titration is important because this fifth point, it is quickly where you are quickly close the tap when the end point is reached, means the sharp color change will happen. So it is basically saving your time, quickly telling you how much volume is needed to change the color of the base from the burette. Okay. And for the burette reading, how you have to check the reading? You have to first of all check in front of the eye level to see the meniscus. You know about the meniscus?
No, miss.
So let me tell you about the meniscus over here. Let's say this is the burette. In the burette, let's say in the burette we have acid. So the reading, the solution or acid will not be making a straight line over here. It is making a curved line. That is known as meniscus. Okay. Whenever, let's say, inside the tube, inside the test tube, you put water, it will not make the level straight. It will make a little curve like this. This is known as meniscus. So if you want to see this reading, what you will do, you will check out this lower meniscus. You will check from here. How much is the reading? Let's say here the reading is 10.2. Here the reading is 10.1. So 10.1 reading you will check, not the 2. You will see the lower meniscus, lower reading, because that is accurate. If you check this 10.2, it's wrong because this space is empty over here. That is not solution here. So we need lower meniscus to check over here. Okay, so for the acid or for anything colorless, we always check lower meniscus first, the colorless solutions. And if it will be colored solution, we will not be able to see lower. So then we will see this upper line. Upper line is known as upper meniscus for the colored solutions. We will see upper line for the colored solution. But for colorless solution, we see this lower line, which is known as meniscus over here. Okay, this point is clear now?
Yes, miss.
Okay. Let's move back to the same text that we are doing.
Wait,
Okay.
Miss, for the
Yes, yes.
colored, Miss, for the colored,
Hmm.
why do we use the upper meniscus?
Because lower is not visible. For the colored one, this will show you the line only. We cannot even see this one because it's a colored solution. So for the
Okay.
colored, only upper line will be visible. So we'll see upper. But for the colorless solution, the lower line will be visible. So we'll see the lower one for the accurate reading.
Okay, Miss.
Okay. Okay, so like this, we can check the meniscus. Then we can, for a good reading, after rough titration, we will repeat the experiment for the accurate titration. As soon as you approach near the rough reading, let's say the rough was 30, you go till 28, you will be careful. You will be attentive. You will be attentive that I'm very close to the actual reading now. So then you will add the one drop from the burette at a time. Keep mixing and see the color change, which is very accurate color change. Okay. Okay. For the burette, you will not write the readings 25, 26, 27. You will write nearest to 0.05. What does mean by this? It means you will write 25.00, 2 decimal places. You will write 25.05 like this. 2 decimal places. So nearest to 0.05, you will be writing all the readings. Okay. Then you can repeat the whole experiment again by taking a new conical flask. Again, take 25 solution, do the whole experiment again and get the reading. So 2 to 3 times you should do this experiment to get the right answer. Okay. So then you will make this kind of the table. So the reading that you are getting from the burette is basically known as titer. So it's the burette reading, which is basically known as the titer. Okay. Rough titer, let's say, is 15.5. It means your values actual should be closer to 15.5. When you're doing the actual one, means that you are doing the experiment for the first time, accurate one, that is known as titer 1, it is 14.90, 2 decimal places. Then for the titer 2, you're repeating the experiment second time, you're getting 15.00. And then you will take the average of these two. Because you're repeating 2 times, 3 times, just take the average, that will be known as the mean one. Mean one means, how you can do this? Titer 1 plus titer 2 divided by 2. If it will be 3 titers, titer 1 plus titer 2 plus titer 3 divided by 2. Remember, this rough reading you will never take to take the mean. Why? Because rough reading is a wrong reading. It's not actual reading. It's just telling you the idea that your real readings will be close to rough. So rough reading you will never take in the mean. Okay. Wait, I will take your question. Let me just tell you one more thing. So when you're performing the experiment 1 time, 2 time, 3 time, how you will get to know that your experiment is correct or wrong? So when you're performing the experiment 1 or 2 time, you will choose only those values which are close to each other by 0.1. So you will only repeat again and again and only choose those 2 results which are close by 0.1. What does mean by this? Let's say I'm doing the experiment. I got first reading 14.90. I got the second reading 14.70. I got the third reading 14.30. These two values, check out the 0.1 means you are going to check this number 9, 7 and 3. Okay, if you check out the first two readings 14.9 and 14.7 has a difference of 0.20, right? Means we cannot take them. We need only those readings which are away from each other by 0.1 difference, not 0.2. I cannot take these two values. If I take the 0.7 and 0.3, 0.7 and 3, how much is the difference?
0.40 or 40.
2.4. Again, we cannot take this. If you take the first and the third, 0.9 and 0.3,
0.60.
0.6 difference, so means your experiment is wrong. Do it again. So keep doing until you get at least two values. Let's say I got 14.90, 14.80, 14.60.
This one's correct.
Then we cannot choose the second and third because it is 0.2 strong, but we can take the first and second because it is 0.1. Okay, these two are fine now. So we will keep repeating the experiment at least at that point where we get two values close to 0.1 centimeter cube. Okay, it can be this way as well. Let's say you are getting the first reading 14.90. The second is 14.95. It means
yes,
now
what will happen?
Now it is even more accurate because now the difference is 0.05. Very small, even
So
less
we can
than
take
that.
it?
We'll take it because they are more accurate even. So difference should be maximum 0.1, but minimum can be any number. Maybe you are getting same two values 14.9, 14.9. Okay, perfect. That's good. 14.90, 14.95 is having very small difference. So perfect. 14.8, 14.6, a big difference. No, that is not a good number. Okay.
Miss, what if it's 15?
Okay, tell me the example. Yes, if it is 15 and
Yes. No,
And what about
as compared to 14.90.
yes, yes, yes. See, 14.90 and 15.00. How much is the difference? You
10.
can check from the calculator. 0.1. That's fine. Perfect.
One.
Miss, she meant by maybe
Subtract from the
15.
calculator. Take 15 minus 14.9. It's 0.1 difference. So these two values are fine. Okay.
Miss, maybe she meant by if it was 14.90 and 15.05. So
Okay.
0.15. So we will
15.05, Mama, you're saying. Then the difference is 0.15. No, that is
so
not good. It is a little bigger difference now. We
Will
need
be wrong.
0.1 difference maximum. So do the experiment again and get two values with 0.1. Okay.
that's what you
So if you just come back over here, you see the titer 1 and titer 2. Titer 1 is 14.90. Titer 2 is 15.0. Are the values good to take the
yes.
average? Yes. So we can select these two values and take the average, and that's okay. Okay. Now, how we got the concentration? For this, we will be doing some questions as well, and that is you got this volume. This is the volume of acid from the burette. You can use the volume of acid from the burette, and we have the concentration of this acid as well. This concentration will be given to you. So you got the volume of this acid. Okay, let's say it is 14.95 centimeter cube. Concentration
Yeah,
of this acid will be given to you as well. Let's say it is 1 mole per dm cube. What you can do? Can you use these two values and find the moles of acid? By using the volume in dm cube, we can change this into dm cube easily. And by using the concentration, can we apply any formula here and find the moles of the acid?
Yes, miss.
Yes, we can easily
Yes,
just
yes.
go back to the formula list that we
Not too
have done,
bad.
and we can find the moles of the acid. Okay, after finding these moles of the acid, we can easily relate it with the moles of the base. Let me write one equation over here. HCl plus NaOH is giving you NaCl plus water. This is an acid and this is a base over here. We got the moles of this acid from this one. Okay, let's say we got 0.05, whatever. I'm just writing a rough value over here. Can we use these moles and find the moles of this base? What is the ratio here between acid and base?
Miss
What is the
1 to
molar
1.
ratio? 1, 1.
Miss.
This is 1. This is 1 as well. So the moles will be same for this. 1-1 ratio. So the mole of the base will also be 0.05. So for now, using the base moles and the volume that we added in the start for the base in the conical flask was 25. We can now find the concentration, which is basically moles divided by volume in dm cube. So we'll get the concentration. Okay. So let me just revise the whole thing again for you, that how we got
Miss, it will be
concentration.
0.002.
Yeah. So according to the values, I'm not writing the real values, I'm writing the rough values as an example. Okay. So what we said, the titration is basically telling you the volume of acid used from the burette. You are using that volume and given concentration to find the moles of acid first of all. Then you will go to the balanced chemical equation. You will see, if you know the moles of acid, how much should be the moles of base by checking the ratio. By getting the moles and the volume we have used at the start in the conical flask for the base. That volume and these calculated moles we will use in the formula to get the concentration of this base. That's how unknown concentration of base we can easily find by this titration method.
Miss, does it specifically have to be base? Like, can we find the acid? Can we find the...
Yeah, we can do in the reverse way as well. Okay, in the opposite way as well. So it is applicable for both.
Okay.
So for your syllabus, we are using the base in the conical flask, acid in the burette. But it can be vice versa as well. And it is not only acid and base, it can be any other thing as well. Many types of titrations we have. But for your syllabus, we are only concerned with acid and base titration.
خلاص الحمد لله
Okay.
left.
So everything is clear till now. What is the purpose of titration? How we can do? What is rough titration? And which things we have to keep in mind? How to do everything in this one? Is there any question from this whole topic of titration you can ask?
Miss, can I ask a
Nope.
question?
Yes, sure.
It's clear.
Okay, Varif. Yes, Samreen.
Miss, for the nearest 0.05 cm cube, how will we find it?
How you will
Because
find it?
the burette reading will be not like 0.05, right?
No, the burette reading is there. Burette reading, okay, that's a good question. Let me tell you how you can check this. The burette reading is till the 1 decimal place only. Let's say the burette is giving you the reading 50.1 here, 50.2 here as an example. Okay. Now, if you want to see, let's say your solution reading is somewhere here. It means that is 50.2 with 0. You can suppose it that it is 50.2 with 0. If the solution is somewhere over here, you can say, okay, it is 50.10. But if the solution is somewhere in between, here or maybe little above and below, it means that is the center of 10 and 20. What will be the middle center of 10 and 20?
50.15.
15, like this. So this
Miss,
0,
how about if it was a little bit above? A little
above and
bit
below, we cannot
above.
see. We cannot say anything about this. So you have to write 15 in that case. It can be 1, 2, 1, 3, but we don't know because there is no marking in between. So
Oh.
exam you write, there will be one question in your ATP exam where they will ask you to read these values. If you say, okay, this central value was, the central line was near to this one, so I can say it is 50.17. No, you cannot say. How you will be sure about if it's 50.17? Wrong. No marks. You will say it is in between, so it's 15. Because for any value in between, we write 15. Means 0.05 over here. We cannot say it's 17, 13, 12 because there are no values, there are no readings in between. So whatever will be in between will be 0.05.
50.157.
Umama, what you said? What's your question?
If it was like 15.157.
No, not 3 decimal places, only 2. 2 decimal places.
Always.
Yeah, not 3, not 3. Till 1 decimal place, the burette will show you the reading. If it is exactly on that, it means after that is 0. Okay, if it is in between the two numbers, it means that is basically 5 after that, not 0. So it can be 0 and 5 only, not 7, 3, 2, any other number. 0 and 5 can be the second decimal number. Okay, any other question here?
Miss, another question.
Nope,
Like,
Miss.
Yes, Amreen.
Miss, like you told, we have to find like whether the difference it is 0.1, and we find the difference 0.1, so we can calculate the mean, right?
Yes. So we have to do the experiment. Let's say you did the experiment 2 times, but your values are away from each other by 0.4. The difference is 0.4. It means that is not a right experiment. Do it 3rd time. And then see if there are any 2 values which are 0.1, take it. Otherwise, do it 4th time. So keep
And then we
repeating
find the mean.
Then you will find the mean average. So we'll keep repeating the experiment until 2 values are close with a difference of only 0.1.
Okay.
Miss,
Luna, your question?
Miss, when we have to first of all we start with a rough what was it called, titration, that we open the tap and then as soon as the color change we close it.
We'll close it.
As soon as
because it is rough, it means you are closing little late. Maybe more
Yeah.
solution going down than it should be because it's rough. So, but it will give you somehow the range of the value only.
Yes, Miss. So I was like,
Hmm.
because if we were so careful that maybe the color change was a little bit light, so we will continue opening the acid until it's become really concentrated and fully color changed.
Fully color change, yes. If there is, let's say, a little color change, but you are just shaking it, sometimes it will happen. Let's say you are adding some solution, you will see that, okay, there is a pink color in the conical flask, but if you just shake it, pink color disappear. It means that was not actually the color. That was just for a few seconds. So you will keep
Mm,
shaking until there is a permanent color over here. That is not going to
okay,
disappear.
until there is a permanent. Okay,
There is a
just to be
permanent.
sure.